Okay, sir. Okay, dear students,
Sir, sir.
it is about the dear students. This is about the surface chemistry, but already started the surface chemistry first session, which is under electrochemistry and chemical kinetics of last session. Please observe this indication. Okay, so we are enter into our second session of the surface chemistry. Okay, in this session we have to discuss about the entire parts of the catalyst. Okay, my dear students, so you know already what is the meaning of catalyst. Okay, here a catalyst is a substance which speeds up the reaction, but it is chemically unchanged at the end of the reaction. That means what you observe this one, catalyst is a substance, but it will increase the speed of the reaction. Your key point is what? To increase the speed of the reaction, but it is not a, it is unchanged. The chemically it is unchanged. Chemically it is unchanged at the end of the reaction. That means what? Simple. Catalyst is a substance, okay, which is used to speed of the reaction, but it is chemically unchanged. Okay, that is called as what? Catalyst. Okay, similarly here, when the reaction has finished, you would have exactly the same mass of catalyst as you had at the beginning. That means what? Before reaction as well as after the reaction, the mass of the catalyst is always same. Could not change the mass of the catalyst. Okay, so then catalysis. Catalysis is the change in the rate of the chemical reaction due to the participation of catalyst. What understood this one? Just catalysis is nothing but about to change the rate of a chemical reaction. Why? Because due to the participation of catalyst, due to the participation of the catalyst, or another word, the activity or the process of catalyst is called catalysis. Okay, here one example is given here. When hydrogen is reacted with nitrogen molecules, hydrogen is reacted with nitrogen molecules, gives rise to form ammonia. Here I mentioned here, when hydrogen is reacted with nitrogen in presence of the ferrous, in presence of the ferrous. What is the need of the ferrous here? Because of here, without ferrous, the reaction is take the more time to complete this reaction. That means what? Without catalyst, it will time consuming process. Without catalyst, it is a time consuming process. Here by using, here by using catalyst, this this chemical reaction is completed within the fraction of minutes, within the fraction of the minutes. Why? Because by addition of the catalyst, it will complete the within fraction of minutes. That means what? You have to conclude one thing here always. By addition of the catalyst, the increase the speed of the reaction, to increase the speed of the reaction. That's why here ferrous is acting as a catalyst. Here ferrous is acting as a catalyst, right? So then here the properties of catalyst. Actually, the properties of catalyst under this first one is poison, or it is also called as inhibitors, or it is also called as inhibitors, right? Sometimes the rate of the catalyzed reaction is reduces by the presence of a small amount of same substance, maybe as impurities in the reactants. That means what? Here sometimes the rate of the catalyzed reactions, the rate of the catalyzed reaction is reduces or decreases. Okay, or decreases. Why? Because there is available some impurities, some poisons. Due to presence of the some poisons or impurities, it will decreases the catalyzed reactions or reduces the catalyzed reactions. Those substances are called what? Poisons or are inhibitors. Okay, okay, students. But why? Because it is called as poisons, because of here such a substance which destroy the activity of catalyst is called poisons, and the process is called catalytic poisoning. For example, here when hydrogen is react with oxygen molecules to form water molecules. But here just you have to observe here, this point is very, very important one. Here, in presence of the platinum, it will completed within fraction of minutes to the formation of the water molecule. But what you observe here, the rest of the platinum, there is available carbon monoxide. Carbon monoxide. This is one. Carbon monoxide. What is the main function of carbon monoxide? The carbon monoxide is used when you use this one, it will decreases the activity of platinum catalyst. Okay, the carbon monoxide is used to decrease the activity of platinum catalyst. That's why here CO, that is carbon monoxide, is best example under poison. Okay, my dear students, carbon monoxide is example under poison. Similarly, activity of catalyst, platinum here poisoned by the presence of the CO. Just I told you here, due to presence of the CO, platinum is decreases their activity. Okay. Then here second one, when N2 is reacted with H2, okay, in presence of ferrous as well as H2S to form here also ammonia. But here ferrous is acting as a catalyst, but which is used to increase the rate of the reaction. Whereas here, what about this one? H2S. But here, similarly, like this CO, here H2S also acting as a poison. H2S also acting as a poison. What you understood? H2S, by using H2S, it will decreases the activity of ferrous catalyst. So that's why H2S also best example under poison or are inhibitors. Okay, my dear students. Right then, characteristics of catalysts. Here, catalyst is acting as a promoter. Why? Because there are certain substances which increase the activity of catalyst. Such substances are known as catalyst promoters. For example, for example, what you understood here, when nitrogen is reacted with hydrogen, when nitrogen is reacted with hydrogen in presence of the, okay, in presence of the ferrous, here in presence of the ferrous, as well as by using molybdenum, here it is important one. MO is indicating as what? Molybdenum to form the ammonia. This process is called Haber process. But in this reaction, what you observed here, you know well known about the ferrous. But here ferrous is acting as a catalyst. Similarly, here MO, molybdenum, is acting as a promoter. Okay, molybdenum is acting as a promoter, which is used to enhance the or increase the rate of the ferrous catalyst. Okay, this type of parameters or phenomenon is called catalyst promoter. Once again, repeat you, catalyst promoter. Here, MO is acting as a promoter. Okay, then here types of catalysis. Here there is available two types of catalysis. Number one is homogeneous catalyst. Number two is heterogeneous catalyst. So first one, homogeneous catalyst. What is the meaning of homo? Here homo is equal to equal var are same. Homo is equal to equal var are same. Right? Here the catalytic process in which the catalyst is present in the same phase as that of the reactants is known as homogeneous catalysis. Homogeneous catalysis. Right. What you understood here? Just here the participation of the reactants. Okay. The participation of reactants as well as their catalyst both are present in the same phase. Both are present in the same phase. How you can determine here? Here these reactants also present in the which phase? Gaseous phase. Similarly, the catalyst, that is NO, also present in the which phase? Gaseous phase. Therefore, both are in same phase. That's why it is called as what? Homogeneous catalyst. Homogeneous catalysis. Right? Here, reactants also present in the gaseous phase, and the catalyst also present in the gaseous phase. That's why it is under homogeneous catalyst. So similarly, here this one, here this is the second one, that is B. Okay, here also same. Acetaldehyde is also present in the gaseous phase. Similarly, here iodine also present in the gaseous phase. That means what? Here the participation of reactants as well as catalyst both are in the same phase. Therefore, these two examples under homogeneous catalyst. Here, okay, this is about the homogeneous. This is about the homogeneous, right? But here, when the sulfur dioxide is reacted with oxygen molecules in presence of the NO, that is nitrogen monoxide, to form sulfur trioxide. This process is called lead chamber process. Okay, lead chamber process. So this is about the homogeneous catalyst. Once I repeat you here, simple key point is homo. Homo means what? Equal or same, right? So this is about the homogeneous catalyst. Then here second one, that is heterogeneous catalysis or catalyst. What is the meaning of hetero? Here, hetero is equal different. Hetero is equal to different. For example, the catalytic process in which the catalyst is present in phase different from that of reactants is known as heterogeneous catalysis. Here that means what? Here participation of reactants, okay, participation of reactants as well as catalyst both are present in different phases. Both are present in different phases or states. That process is called heterogeneous catalysis or heterogeneous catalyst. Here these participating reactants are present in the which phase? Gaseous phase. But here catalyst is present in the which phase? Solid phase. That means what? Here the catalyst as well as reactants both are in different phases. Therefore, it is under heterogeneous catalysis. Similarly, here nitrogen
So what happened?
here, okay, right. The nitrogen as well as dihydrogen. Here these two molecules are present in the gaseous phase. Similarly, ferrous is present in the solid phase. That means what? Here
Green, sir. Share screen, sir.
Okay, good. Here, the participating of reactants as well as catalyst both are in different phase. That's why this is also best example under heterogeneous catalysis. That means what I told you, key point is hetero means different, homo means same or equal. Okay, so this is about the heterogeneous catalysis. Okay, right then. Here, activity and selectivity. What is the meaning of activity? The ability of a catalyst in increase rate of the reaction is defined as the activity of catalyst. What is the meaning of activity? It is a one type of the ability of catalyst. It is a one type of the ability of the catalyst. That means what? The activity is nothing but a simple, it is a ability. Okay, it is a possibility. So that is called the activity. Yes, similarly, the activity of a catalyst depends upon the strength of chemisabsorption to a large extent. That means what? Always activity is depends upon the strength of the chemisabsorption. Strength of the chemisabsorption. Okay, then the reactants must get adsorbed reasonably strongly on the catalyst to become a reactive. That means that actually here, when the reactants are occupy the surface area of the catalyst,
Share screen, sir.
after few minutes and after some time, those reactants are converting into products. Those reactants are converting into products. Okay, so this is about the meaning of this step, right? Then the maximum activity being shown by 7 to
Share screen, sir.
that means what? Here, according to our periodical table, there is available 7th group, 8th group, and 9th group metals are acting as a okay, acting as a good activity, which are used to increase the okay, which are used to increase the rate of the catalyst. Okay, so this is about the activity. Here, dihydrogen is reactor. Hello, are you learn my words? Okay, so this is about the activity. Then
Ramesh sir, can you share your screen, sir? Screen is not sharing.
okay, sir. Screen share hotline. సార్ ఇప్పుడు వస్తుందా సార్? సార్ నా ఓకేనా సార్?
No, sir, no, sir. It is not visible.
ఓకే మేడం, స్క్రీన్ రావట్లేదు. సారీ ఫర్ ది ఇన్కన్వీనియన్స్.
Maybe your internet signal is weak, sir.
నా ఓకేనా మేడం?
Okay, sir. Okay.
హలో,
Okay, sir.
ఓకే మేడం. Yes, friends, sorry for the inconvenience. So this is about the activity. Let's we are enter into selectivity. What is the meaning of selectivity? The selectivity of catalyst is its ability to direct a reaction to form specific product. That means what? Here selectivity is nothing but it is also one type of the ability of catalyst. It is also one type of the ability of catalyst. Okay, by using selectivity we have to get the specific products. We have to get the specific product. That means what? We have to use particular catalyst to form the particular product. Okay, that process is called selectivity. Here for example I have to provide a lot of examples here. When carbon monoxide is reacted with hydrogen in presence of the nickel catalyst. In presence of the nickel catalyst, we have to get the methane as well as water molecule. Okay, so here we have to use the which catalyst here? Nickel catalyst. But in second one, there is a no change in reactants as well as the same reactants are there here. Again, carbon monoxide as well as dihydrogen. But here by addition of catalyst is different. Here we have to use the nickel catalyst. Here we have to use the copper catalyst in presence of the ZNO. Okay, comma Cr2 O3. Here we have to obey the methanol. Here we have to obey the methanol. What understood here? Here there is no change in reactants, but changes in catalyst. That means what? Here we have to use the specific catalyst. We have to use here specific catalyst. Then to form here specific product like methane as well as water. But here by using copper, we have to form here methanol. Okay. Here what you understood here? There is no change in reactants, but by changing catalyst here to form specific products like here by using nickel to form methane as well as water. Here by using copper to form here methanol. Similarly here third one, that is here also there, when carbon monoxide is reacted with dihydrogen in presence of the simple copper to form formaldehyde. By using different catalyst to form the different products. That means what? Specific products. Okay, so this is about the selectivity. What you understood here? Activity as well as selectivity, both are abilities of the catalyst. Okay, so this is about the selectivity. Okay, that means a simple selective, right? Then here zeolites. What is the meaning of zeolites? The catalytic reaction that depends upon the pore structure of catalyst and the size of the reactant and the product molecules is called shape selective catalyst. What understood this one? Here important. What is the meaning of pore? Pore means what? Small holes. That is called pore. Always here the catalytic reactions are depends upon the pore structure of the catalyst. As well as size of the reactants as well as products. That phenomenon is called selective catalysts. Here zeolites are shape selective catalyst because of their honeycomb like structure. What is you understood here? Here zeolites are also example under shape selective catalyst because of the zeolites are present in the honeycomb like structure. Right? There are microporous aluminosilicates with a three-dimensional network of silicates. There is available microporous aluminosilicates which are present in the three-dimensional networks of the silicates. Right? Here this is about the second point of the zeolite. Then third point, zeolites are microporous aluminosilicates. Okay, zeolites are microporous aluminosilicates with a dimensional network of silicates. Silicates, which some silicate atoms are replaced by aluminum atoms, giving aluminum, okay, oxysilicate framework. That means what? Yeah, there is available aluminum atoms. Those aluminum atoms are replaced by, silicate, silicon atoms are there. Those silicon atoms are replaced by aluminum to form the what? Aluminosilicate dimensional networks. Aluminosilicate dimensional network. So this is about the zeolites. Okay, zeolites are simply, what is that here? Shape selective catalyst. Zeolites are example under shape selective catalyst, right? Then the reactions taking place in zeolites depends upon the size. I told you just now, size and shape of the reactant and the products, molecules, as well as on the pores and cavities of the zeolites. Always, okay, always zeolites are depends upon the size and shape of the reactants as well as products. Reactants as well as product, along with pore structure of the pore as well as cavities of the zeolites. Right here, zeolites are found in nature and also synthesized for catalytic selectivity. Here, zeolites are how to prepared in synthesized process as well as which are available also in the nature. Okay, but here zeolites are acting as a catalytic selectivity. Zeolites are acting as a catalytic selectivity. So this is about the important portion about the zeolite. Now, uses of zeolites. It is very, very important one. Okay, so which is asked for 2 mark purpose in your IPE examination. Right. What are the uses of the zeolites? Here, zeolites are used as catalyst in petrochemical industries for cracking. What are understood here? The zeolites are used for in the which field? Petrochemical industries. Petrochemical industries. Okay. Then second one, the zeolites ZSM5 is used to convert alcohol directly into gasoline, that is petrol, by dehydrating them to give a mixture of hydrocarbons. That means what? There is available one simple zeolite, that is what? ZSM5. Here is a ZSM5. ZSM5 is used to convert the alcohol directly into gasoline. This is a best use of the zeolite. This is a best use of the zeolite. Okay. Then here, enzyme catalyzed reactions. Enzyme catalyzed reactions. Actually, enzymes also acting as a biocatalyst. Okay, enzymes also acting as a biocatalyst here. Biocatalyst. What is the meaning of biocatalyst? The biocatalyst is a catalyst or substance which are responsible for to run the metabolic chemical reactions. Metabolic, simply metabolic reactions, which is present under living organism. Okay, so right here, how you can identify the biocatalyst? Simple, very simple. Here the catalyst, which is containing the suffix is yes. The suffix is yes. That is indicating as the always biocatalyst. That is indicating as the always biocatalyst. For example, I have to provide lot of examples under enzyme catalyzed reaction. Apart from that, the first one is inversion of cane sugar. Here, we have to use here which type catalyst here? Here, always here the suffix is yes. Yes, the suffix is yes. That's why invert is also one of the example under biocatalyst. I told you here yes is equal to biocatalyst. Simply here also the suffix is yes. That's why invertase is a one of the biocatalyst. What is the main use of the invertase enzyme? Okay, here the conversion of cane sugar is represented by, that means what? When this is formula for cane sugar, when cane sugar is reacted with the water molecules and to form glucose as well as fructose. Okay, here by using which catalyst, I mean which biocatalyst here? Invertase biocatalyst. Then second one, conversion of glucose into ethyl alcohol. Here you have to use the which catalyst here? Gymase, that is biocatalyst, gymase. Here also there is available, the suffix is yes. That's why it is also one of the best example under biocatalyst. By using gymase biocatalyst, here the glucose is converting as ethyl alcohol as well as carbon dioxide. Ethyl alcohol as well as carbon dioxide. Okay, so this is about the best two example under enzyme catalyzed reactions. Then there is also there someone here by using diastase. Here yes, diastase. By using diastase biocatalyst, here starch is converting into maltose. Starch is converting into maltose by using diastase biocatalyst. Okay, fourth one, the conversion of maltose into glucose by using which catalyst here? Maltase. Yes, that's why it is also one of the best biocatalyst. By using maltase, here maltose is converting into glucose. Maltose is converting into glucose by using maltase. Yes, yes means what? Biocatalyst. Maltase biocatalyst. Okay, so this is about the best example under these reactions. Right, then another one, fifth one, here decomposition of urea into ammonia by using urease. Yes, here it is a urea. Urea is reacted with water molecule in presence of the urease biocatalyst to form ammonia as well as carbon dioxide. Here, last one, that is conversion of milk to curd by using here lactobacilli. By using lactobacilli, here the milk is converting into curd. Okay, so then mechanism of enzyme catalysis with suitable diagrams. Here generally E is indicating as the enzyme, S is indicating as the substrate. Okay, when here it is a enzyme. This part is called as what? Enzyme. Here enzyme is acting as a catalyst. Here enzyme is acting as a catalyst. Okay, similarly this diagram, this figure is indicating as the substrate. Nothing but what here? Nothing but what here? It is nothing but what? Reactants. Substrate is a reactant, enzyme is a catalyst. When catalyst is, that is enzyme is reacted with a substrate, then to form enzyme substrate complex. Enzyme substrate complex. Or it is also called as complex. It is also called as complex. That means what? Here enzyme is exactly fit the active site of the substrate. Active site of the substrate to form enzyme substrate complex. After few minutes, this entire part is divided to each other and to form here what happened here? It is both diagram, both figures are combined to each other. After few minutes, here enzyme is separated from the substrate, and then this substrate is converting as a product. Here substrate is acting as a reactants. Here after dividing of this complex, those reactants are converting as a product. What understood here? Here enzyme, here substrate is reactant first, and finishing here this is nothing but what? Product. That means what? Substrate is reactants, and here this is a product. This is about the mechanism of enzyme catalysis with a suitable diagram. I told here. Here step one, enzyme is reacted with S for what? Substrate to form ES star. ES star means what? Enzyme substrate complex. Then second step, okay, the decomposition of activated complex to to form product. That means what? The complex is decomposes to form E plus P. E means what? Enzyme. P means what? Product. Okay. So this is about the mechanism of enzyme catalysis with a suitable diagram. Then important, that is important one, very, very important one in this chapter, colloids. This is also called as salts. Okay, colloids are salts. The definition here: a heterogeneous system in which one substance is dispersed as large particles in another substance is called a colloidal solution. Actually, colloidal solution is a always important key point is what? Heterogeneous system. That means what? Different substances are available. When there is available different substance, then only we have to define as the or explain as the colloids. And also colloids are applicable for only binary systems. Colloids or salts are applicable for only binary system, but not homogeneous system. Right? Second point. In colloidal solution, the particle size of dispersed phase is of the order of 1 microunion to 1 union. That means what? The size of the colloids particles are always containing 1 mu to 1 mu. Okay. So then, whereas in true solution, the particle size of solute are the order of only 1 microunion or less. Okay. So this is about the colloids or salts. Right here. And after this,
Ramesh sir, complete.
hello, what is the meaning of dispersed medium? Okay, here dispersed medium, nothing but what? Dispersed medium is a major quantity in the solution. Major quantity in the solution. The dispersed medium, which is represented by dm, Similarly, what about the dispersed phase? Dispersed phase means what? Minor quantity in the solution. The particles which are acting as a minor quantity in the solution, that is called dispersed phase, which is represented by dP. Here, for example, I have to provide one example under salt solution. In salt solution, here salt is acting as a disperse phase. dP means what? Disperse phase. That means what? Here the salt is a particle which are containing minor quantity in the salt solution. Similarly, water is acting as a dispersed medium. Water is acting as a dispersed medium. Why? Because water portion is very large extent when compared with the salt. That's why water is acting as a dispersed medium in the salt solution. Right? Then, actually, there is available two types of salts or colloids. Apart from that, the first one is positively charged salts. What are those examples here? Hydrated metallic oxide salts. Example is what? Hydrated metallic oxide salts. Second one is basic dyestuffs. And third one is hemoglobin. These all are example under positively charged salts. Second one is negatively charged salts or colloids. What are those? Only metal salts. All metals are acting as a negatively charged salts. Right? So, Helmholtz electrical double layer. It is proposed by Helmholtz scientists. Therefore, it is called about Helmholtz electrical double layer. According to Helmholtz, the definition is the combination of two layers of opposite charges around the colloidal particles is called Helmholtz electrical double layer. That means what? The combination of two layers of opposite charges which are present around the colloidal particles. That means what? Two opposite charged particles are present around the colloidal solution is called Helmholtz electrical double layer. The meaning is there, double layer. Okay, two layers. Okay, then what about the zeta potential or kinetic potential? Here, the potential difference between the fixed layer and the diffuse layer of opposite charge is called zeta potential. That means what? The difference in between fixed layer as well as diffuse layer of opposite charges is called zeta potential. Okay, so this is about the zeta potential. Then, so this session is complete now. Tomorrow we will meet.